When I work on an audio project, I sometimes needed to use a loudspeaker to test the audio coming out from an amplifier or such. I always used bare speakers to do so in the past, but I found it useful to have something that is not laying down on my desktop with all the bare metal exposed, that sometimes gets in the way, creating short circuits with the various wires that are laying there too. So, I decided to build a plastic container and put the loudspeaker in there, therefore providing an isolation for the metal of the speaker itself. This is the result of my work, and I would like to show you how I did it, so let's get into it. Here on the left is the simple OpenSCAD code that I used to build the plastic box using my 3D printer. On the right side, you can see how the box looks like on the CAD viewport. The code is very simple. For the main container, I just used a cubic shape with size of 180, 80 and 80 millimeters. Then, I carved that cube, removing from the inside another cubic shape, such that the remaining walls of the box were 4 millimeters thick. I choose that thickness to make sure there are no vibrations of the box while the speaker is powered. In fact, we want to have the whole sound coming out from the speaker and not from the vibration of the box that contains it. To make possible to connect to the speaker, I added a couple of cylindrical holes on one side of the box, so that I could put in there a couple of connectors for the two wires coming out of the speaker. And finally, I also carved a rectangular shape at the top of the box, so I could insert the cover in it. The cover is a simple cubic shape that fits in the indentation at the top of the box. I put in it 4 holes to lock in place the speaker via 4 screws. And finally, I added a series of slits to allow the sound waves to leave the box. Once that was done, I sliced the STL file I created with OpenSCAD and loaded the corresponding G-code on the 3D printer. And here are some images of the 3D printing process that physically created the box and its cover. First thing I did once the box was ready was to put in place the 2 connectors for the loudspeaker. Given the depth of the box, it wasn't that easy with my big hands to screw the connectors in place, but I was finally able to do it. Please don't laugh at my attempts. I then tightened up the nuts of the connectors and then put a drop of glue on them to make sure that they won't loosen up over time because of the vibrations of the loudspeaker. Next, I started working at the box cover, which is the piece that also holds in place the actual speaker. I cut a piece of cotton fabric in the appropriate size and I glued it on the slits from the inside. This smoothens up the sound on the finished product and also protects the loudspeaker from the dust. Once the glue was set, I punched holes in the fabric to allow the screws to go through. Then I inserted the screws from the external side of the cover, put a washer on each of them, and then hold them in place with nuts. This was much easier than assembling the connectors. I then tightened the screws in place. Once that was done, I put in place the loudspeaker and secured it on the screws with the help of 4 more nuts, which I tightened in place until the flaps of the speaker started bending just a little bit. This provided some tension on the screws, which in turn increases the friction with the nuts and holds them in place with no chances to have them loosen up over time. Now was the time for the electric connections. I used a spare piece of loudspeaker wire. I peeled the insulation on both sides, twisted the copper wire that got exposed, and soldered one end of the wires to the loudspeaker. Then I started working to connect the other end of the wires to the connectors inside the box. Again, that wasn't an easy thing to do because of my end size in comparison with the deepness of the box. But with a little patience, I was again able to get the job done. Once the wires were finally in place on the connectors, I soldered them. And now was the time to close the box, but before doing that, I took a piece of fiberglass insulation and put it inside the box. That reduces even further the possibility that the box starts vibrating, causing that bad sound that you can hear on cheap loudspeaker boxes, like those for the boom boxes. Once the fiberglass was in place, I set the cover on the box. Before gluing the cover on the box, I made a quick test to make sure the connections were correctly in place. For that, I just connected the output of an old MP3 player to the loudspeaker to make sure I could hear a clear and nice sound. Since the test was successful, I went on and glued the cover to the box, so it won't be detached for any reason while I am using it. Last thing, I attached the label to the box, stating the impedance and the power of the loudspeaker. And that was all. The loudspeaker box is now just another piece of the equipment in my lab. I plan to use it often for all my projects related to audio. If you liked this video, please don't forget to give me a thumb up, and if you want to be informed when a new video comes out on my channel, please don't forget to subscribe and click on the bell icon. Also, if you like my channel and would like to see many more videos, please consider to become a patron by going to my patreon.com page and pledging monthly even a small amount of money. You can also go for a single donation every now and then through my PayPal account. All the information to do so is in the video description below. This helps me in become more independent, and who knows, one day I can just leave my current job and dedicate my time entirely to this channel, so to provide you, my followers, with more frequent videos of higher quality. Thank you for watching, and as usual, happy experiments!